Hello students, Professor Dr. Sharma back here. Now I am going to introduce the three important groundbreaking laws of motion, Newton's laws of motion. Newton was a legend. Okay, so we will uncover how force shape universe or everything here, from you walking on the ground to stars orbiting galaxies. Let's explore Newton's three laws of motion here. The foundation of physics. I would say that this is the foundation of physics and the physical universe. So there are three different laws. You have the first law. The first law of motion is called the law of inertia. First law is also called the law of inertia, and it says an object at rest stays at rest. An object in motion stays in motion unless acted upon by a net force. Okay, so I think seems you understood this statement, but little clarification needed here. So let's do some kind of space thought experiment. Okay, thought experiment is very important thing, very powerful, just like a lab experiment. So Einstein was a champion for that, for the thought experiment. So imagine you are an astronaut. How many of you wanted to be astronaut in future? Anybody? I think I would love to be astronaut. I didn't get that chance. Okay, I think anybody? Some of you wanted to be astronaut. It's a cool thing. Okay, imagine you are an astronaut floating in space. Then you gently push a wrench. You have a wrench, you push that wrench. What happens? Or anything, you have a book, you push it. What happens to that book? It will fall somewhere. This is the space, this is the space, nothing there. What happens? It will stop some point and hanging on the space, or it keep moving. What happens? Can you tell me? So answer is it keeps moving. So if it keeps moving, how it moves? It moves, suppose you are here, you push from here, it moves like this way, like a straight line, or it moves like that way, or it spiral like that way. How it moves? Can you guess? The answer, it keeps moving in a straight line. Forever. You don't need any energy there. You just give a slight push, it continuously moving forward always. No rocket, no engine, no fuel, no force needed to keep moving after that when you apply the push. Why? Because there is no air, there is no friction, no external forces acting on it. You exerted some forces and that nothing will stop. That force will keep continually pushing that object continuously, that object moving on. Same thing. On Earth, you push something, it goes little distance and then it stops because of the friction, because of the air resistance here on Earth. But in space, where there is nothing there, none of that, no air resistance, no friction, object keep moving. Okay, so Earth orbits the sun because of the gravity and inertia. When it forms, during that formation, already in the motion, and it is still going around the solar system with certain thousands of kilometers. No force needed, no engine needed. Okay, comets race through space, they do not need any fuel to keep going. So the moon orbits the Earth not because it's being pushed, but because of the balance of gravity and motion. So that's the reason, anything which at rest, if initial phase when Earth formed, when it was rest, it definitely be rest all the time. But when it formed, it already in the motion, so it is keep going with that motion forever. That is called the Newton's first law. Anything at rest, remain at the rest. Anything will in motion, remain in the motion, but in the straight line motion. But if you change the balance of forces, if you create the net force, then you have to go second law. So in the first law, net force is 0. Right? Book on a table, sitting on the table, so weight of that, the Newton force, normal force 0. So net force is equal to the weight force plus net force, the normal force. So the weight force is downward, so the negative, and the normal force is positive. So they are equal in value, so it becomes 0. Net force is 0. That's why it is standing still. If anything in the motion in this space, I gave the example, the net force is still 0, but object is keep moving. Okay. But what happens if there is a net force? Here net force is 0. If there is a net force, then what happens? I told you in my lecture related to the net force, then object is start to accelerate. Then the object is start to accelerate. So what happens here is it accelerate, and that acceleration is always equal to the force divided by mass. Okay. So from that you have the relationship F is equal to ma. This is the net force. Actually we talk about the net force ma. This is not an individual force in second law. So this law actually tells us the force, the mass, and the accelerations are related. If anything has a mass, that must connect with the force. If anything has the acceleration, that must connect with the force. Okay. So let me ask this question: who pulls more, the earth on you or you on the earth? You know, any mass that has the ability to create the gravitational pull. As a person, you have a mass. As a person, I have a mass. I can pull the earth. Earth has a mass, so earth pull on us. So who is pulling stronger? So you are here, you are standing on the earth. Who is pushing stronger? You are pushing the earth stronger, or the earth pushing you down stronger? Anybody? The answer is the force is equal, but you accelerate. The force is equal. So the force by the person acting on the earth, force exerted by the person that acts on the earth, and the force exerted by earth acts on the person is the equal. Seems bizarre, right? But you accelerate. So when you are here, you are jumping, I'm jumping here, immediately you accelerate toward the center of the earth. The reason is the mass. You know, the net force exerted is the same, but the mass of the earth is so huge, greater the mass, very small the acceleration, so negligible acceleration, so earth is not accelerating. But your mass is so tiny, then you have a greater acceleration, so you jump, immediately earth accelerated you toward the center of earth. Okay, so that's important thing. So many people think that earth exerted so much force on you, then you exerts the force on earth. That's misconception. The acceleration and the force total different thing. You accelerate more because you have a less mass. Okay, so a small scooter accelerate quickly if you push it. What about a truck? So truck has a greater mass, definitely it has a less acceleration. So you kick a football and a bowling ball with the same force, guess which one flies? Can you tell me? So you kick a football and a bowling ball with the same force, which will flies faster? Can you tell me? So the thing is, heavier things are harder to move because of the mass, because acceleration is very small, because they have a very high inertia, that means very high mass. So the more force means more acceleration. So common misconception, because my goal here is to get rid of the misconception of people. may have. So people think force is needed to keep moving. That's false. Force is only needed to start, to stop, or to change the motion. Okay, that's a very important thing you need to realize. So this is the second law of motion. Okay, second law of motion is the quantitative definition of the force. Net force is equal to the mass times acceleration. Mass is measured in kilogram, acceleration is measured in meter per second square. Kilogram meter per second square is called the Newton. For the honor of our legend scientist called Newton, the unit SI unit for the force, if we measure the mass in kilogram, acceleration meter per second square, that is called the Newton. So the 1 Newton is equal to the 1 kilogram of object which is accelerating with 1 meter per second square. That kind of force needed to accelerate that 1 kilogram object in 1 meter per second square is called the 1 Newton. Now let's go to the third law. Okay, let me summarize the first and second law. Very important thing. So if anything has net force 0, sum of all the forces, that is F net, that is first law. If there is a net force, then you have no zero force. You have the certain amount of net force that is equal to the mass and acceleration. Remember that first law and second law only concerned with the one object. So a box sitting, lying on the ground. So if you take box as object of interest, you only focus on all the forces acting on the box and neglect the ground, neglect the other things. You neglect the other interaction. So in real life, you have to deal with the interaction. Okay? So then you have to go for the third law. Let me begin with the Newton's third law of motion. That is very, very important thing. And so many people think it's easy one, but it's one of the great law so far the human brain has uncovered. So the third law says the every action there is an equal and opposite reaction, right? So let me ask you a question. Suppose I am pushing this board, or I am pushing the wall. Does the wall push me back? Yes or no? Yes. The answer is yes. Equal and opposite. Okay? Otherwise you would fall through. If wall will not react to you, you will go through that wall. There is no thing to stop. So wall stops you. So reaction must be coming from the wall. Then you push the wall, you provide the action, and the wall provide the reactionary force. Then which comes first, action or reaction? The answer is they happens at the same time, no time delay. When you start to push, then the wall immediately push you back at the same time. There is no time delay. So important clarification here, I wanted to do that. So people confuse the third law of motion as a tit for tat, equal and opposite, like a revenge. That's wrong. They did not understand the Newton's law of motion, third law of motion. This law is not emotional. It is nature's the perfect symmetry. Okay? Perfect symmetry. So the law, the nature wants balance. Okay? So it's the most powerful of three laws. Third law is the one of the most powerful law. The first and second law explain how one object moves, how one object behaves, only related to the one object. But the third law explains how two objects interact, two or more objects interact. And all of nature is all about interaction. Okay, that's why third law is very, very important. So I just explain the symmetry in nature. What is symmetry means? So I think if you are physics students, you know that. But if you have not taken physics, the nature symmetry, that means that term seems unusual, unfamiliar. Let me discuss about symmetry in nature. So I told you that the nature loves balance. Okay, you push down on the ground, ground push you back. Fish push water backward, water pushes them forward. Rocket push exhaust down, they pull upward, they fly upward, right? Earth pulls the moon, moon pulls the earth equally. Okay, so this interaction symmetry explains how things moves, why things recoil. Two cars collided, they collided but they recoil. Why they recoil here? Because conservation of momentum. We have a big topics about conservation of momentum. So third law of motion is connected to the conservation of momentum. So conservation of momentum, one of the most sacred law of physics, you can tell that, which comes from third law of motion. Many people don't realize this thing. Okay, so let me discuss. This is the huge topics because this is the introductory level course. I try to explain things. I try to break things down in your level so that you can understand about third law of motion. So third law of motions explain the action reaction force sphere. Let's take some example. Okay, you push on the wall, that is the action. Wall pushes back on you, that is the reaction. Foot pushes ground, you walk, ground pushes your foot forward. So rocket pushes gases downward, gases push rocket upward. What else? Can you give me other example? Hammer hits the nail, nail pushes back up hammer. Earth pulls you with the gravity, you pull earth with gravity. But yeah, earth has a negligible acceleration, you didn't see that. Okay, so these forces act on different objects actually. Okay, and they are equal and opposite. So action and reaction force has certain characteristics. Action and reaction forces acting on different objects. They are equal and they are opposite. So let me conclude this. Newton's laws are not just for physics. They are the laws of how the world responds to us. The first law shows the importance of inertia, importance of mass, why motion is preserved unless something stops. The second law tells us how forces create acceleration and how mass matters. The third law is the supreme law, I would say that. It governs all the interactions, all the symmetry, all the momentum of this universe. So to understand motion is to understand the balance of the universe. Okay, if balance is not maintained, everything will ruin. You know that if earth loses its balance, it can go outside the solar system and nothing will be here. So in real life, also try to balance things. It's not moving faster, it's not moving slower, it's all about balance. So physics tells us to remain in the balance, maintain the balance. That's all for today. I think another lecture I will be discussing about some problem. Okay, any questions?